16.2. Solving quadratics when set to 0. That means equal to 0. Okay. So this is the first part where now that we've learned how to solve quadratics by putting them into the product of two binomials, that we're starting to lean to getting some information so we can graph a quadratic. We're not going to graph them today, but at the same time, I want you to keep thinking forward about how to graph a quadratic. Essential question of the day. How can you use factoring to solve quadratic equations in standard form when a is equal to 1? Now, we've already talked about that, and basically we're just finding a list of factors that would give me the product of a binomial that would literally be two big factors or two polynomial factors of a quadratic, okay? So we can factor the quadratic equation, set each linear factor equal to 0, solve each linear equation. These are the solutions of the original quadratic equation. Whole lot going on there. I'm going to break it down for you. I'm going to make it real simple. Vocab. So the first one that we have is the zero product property. Okay, with that being said, this is something that you already know, and it's very simple. The zero product property literally says when I multiply by 0, what am I always going to get? The answer is always 0. So 0 times 4 is equal to what? 0. 0 times 1/2. 0. 0 times 1,000,000. 0. 0 divided by 1. 0. It's all the same. Now I know we're talking about the product. I just threw in division there, but no matter what, 0 is very, very useful because it is going to get me a 0. With that being said, I can start really finding out some things, but I also want you to start thinking ahead. I've already planted the seed. When I'm on the y-axis and I'm at 0, where am I? That's right. I'm on the x-axis. Somewhere on the x-axis. I gotta be on the x-axis, okay? So that's just a little, secret alert. Just want to let you know that this zero product is we're working our way to graphing quadratics, okay? Find the zeros. Okay, so let's say we had the quadratic already factored, and it was x plus 4 times x plus 8. And that was already factored. We're good. We understand that's it. Now let's say that, and let's use P and Q. Let's say we had P times Q. If I set it equal to 0, find the zeros. You're going to hear us keep saying that. We're going to set these binomials equal to 0. Now, I have two different things going on here, and here's the reason why. I think you can notice that if I have P times Q and I set it equal to 0, if P was equal to 0, then what would happen to Q? No matter what it was, I would know that my answer is still going to be 0. What if Q was 0? Then I know no matter what P is, that my answer would still be equal to 0. Now with that information, it allows me to set the variables equal to 0, and that way I can figure them out. So let's act like P was x plus 4. So if I said x plus 4 is equal to 0, I get one equation. And now I can also say x plus 8 is equal to 0. Wow. So with that being said, then I can easily solve for x, right? So first step, simplify / combine like terms, nothing to do. Second step, what are you going to do? You are going to subtract. So if I subtract 4, I get x is equal to what? -4. So you're telling me, Mr. Harris, that if I plug in this -4 plus 4, -4 plus 4, I would get 0. And 0 times anything is still what? Of course, that's 0. So one of my solutions is going to be x equals -4. Now, let's come over here. I can now solve for this x. So I have first step, simplify / combine like terms, nothing to do. The second step, I'm going to subtract. So I subtract 8, x is equal to what? -8. So there you go again. You have two solutions. Now, remember what I was telling you about with this graphing. I know that I have -4 as a solution. What was the y equal to? I know I'm getting ahead of myself, but I like trying to put it all together. The y is equal to that 0. And where is this located? On the x-axis. So one of my solutions that I can graph is -4, 0. What's my other one? -8, 0. And where is that at? On the x-axis. All of that is me looking toward the future and letting you know that we're going that direction. But find the zeros. Where are we? When we find the zeros, we are on the x-axis, okay? And because it is a U-shaped, that is what a quadratic is. It's a U-shaped graph. Look at what I got. I have -4, 0 and -8, 0. So this would be the -8, 0. This would be the -4, 0. And I'm exactly on the x-axis. Getting way ahead of myself, but I'm getting excited because now that you know how to use a quadratic, you're able to sit there and solve for two different points on their graph. And these are called the zeros of the quadratic. Okay? All right, so let's talk about this. F of x is equal to y. You should already know that f of x is equal to y. Now watch what we have. If I have x squared plus 10x minus 21. If I said f of x is equal to that, you would know that that's the same thing as saying y is equal to x squared plus 10x minus 21. Now think about what we just said. Find the zeros. What are we setting equal to 0? Yep, you got it. We're setting the y equal to 0. So that's why I'm trying to tie all this in. You're going to get it in, this is what? Function notation. Right? That's function notation. You're also just going to get it in standard form. And then this is you setting it equal to 0. And why are we setting it equal to 0? Because it puts us on the x-axis. Does that make sense? Okay. So a lot of this is preliminary. We're now going to focus on making sure that you understand how to find the zeros. Apply the zero product property, which we just said. Multiplying by 0 gets you what? That's right, 0. With the product of two binomials. So what does that mean? You will get a question like this. The function f of x equals x plus 6 times x minus 8. If you have that and you are told to find the zeros, immediately you're just going to set them equal to 0. Okay? And now that you set them equal to 0, that means that if one of these parentheses is equal to 0, 0 times whatever's in the other parentheses is still going to equal the 0 over here. Okay? So that means I can split these two factors apart and set them both equal to 0. So all I have to do is x plus 6 is equal to 0. X minus 8 is equal to 0. And now I can do what? That's correct. Solve for x. So first step, simplify / combine like terms, nothing to do. Second step, I am going to subtract. Subtract what? This 6. Because I need to do it to both sides. I get x equals -6. This is one solution. Now, solve for x over here. Simplify / combine like terms, nothing to do. Step 2, I am going to add. So if I add 8, I get what? X equals 8. This is my second solution. Okay? So when they say find the zeros, you're able to say that it is -6 and +8. Those two are your solution. Do not make these, star here, do not make these a coordinate pair. Don't make them a coordinate pair. This says x equals 8. This says x equals -6. They're both the values of x. You have two different points. Okay, so -6, 0, 8, 0. You already know that these are what? X intercepts. X intercepts cross what? That's right, the x axis. I'm going to keep drilling that in, okay? Example number 2. So I give you the product of x minus 10 times x plus 4. The question posed to you is find the zeros. So what do I do? Set it equal to 0. If I set it equal to 0, then I'm able to split them apart. X minus 10 is equal to 0. X plus 4 is equal to 0. Now, if I do that, I can solve for what? X. First step, simplify / combine like terms, nothing to do. Second step, I'm going to add. So I add 10, add 10. X equals 10. Solve for x over here. So, first step, simplify / combine like terms, nothing to do. Now, subtract, because I'm removing addition and subtraction. So I minus 4, minus 4. X is equal to what? -4. Now watch this. Let's do a little quick proof. See if this makes sense. Let's plug in just this one. X equals 10. So if x is equal to 10, that means 10 minus 10 times 10 plus 4 equals 0. That's what it says up there, right? So let's see what happens. 10 minus 10 is what? 0. 10 plus 4 is what? 14. Does 0 times 14 equal 0? 0 does equal 0. So 10 works. Now let's try -4. So -4 minus 10. All right. And then I have -4 plus 4 equals 0. -4, -10, -14. -4 plus 4, 0. 0 times -14, 0. Does that work? Yes. So I know that when I set it equal to 0, that this 10 and this -4 are going to, no matter what, because of the zero product property, they're going to equal out to 0. Okay? So you get two answers, and I want you to realize we're on the x-axis. I can find the x-intercept of where this quadratic crosses the what? X-axis. So 10, 0, -4, 0. This is where the x-intercepts are for the quadratic. Solve a quadratic. Okay, so let's do it from the start, okay? I showed you how, when we're already factored, how to move forward, okay? Well, what about if we start from the beginning, okay? Let's just figure this out. So I have x squared plus 10x equals negative 21. What you want to do is get it into a trinomial, or you basically want everything on one side, okay? Which means set it equal to what? 0. And how do I do that in this problem? Well, 21 is the only thing on the right side of this equal sign. I want everything on the left. So here we go. So I'm going to add 21 to this side. I'm going to add 21 to that side. And what do I get? X squared plus 10x plus 21 equals 0. There we go. That was pretty simple, right? Law of equality. I did what I did to one side, I did to the other. I'm cool. I'm A-okay. And it's equal to 0. So now, what are we going to do? That's right. We're going to factor. What are we going to factor? We're going to factor this whole quadratic, okay? So how do we do that? That's right. Do what we normally do. A is equal to 1. B is equal to 10. C is equal to what? A positive 21. Good? All right. Now, where do we go from there? That's right. Absolute value of A times absolute value of C. So I get 1 times 21. There we go. Now what do we do? Remember your procedures. I want a list of factors. List of factors is different than using a factor tree. Okay? So here we go. Always start with what number? 1. So now 1 times what gets me to 21? 21. 2? No. 3? Yes. 3 times what? 7. 4? No. 5? No. 6? No. Oh, we're back to 7. 7's already written. We don't want duplicates. So now we want to know, if I add these up, am I going to get to B? So I like to put B up here. B is equal to what? 10, a positive 10. Let's take a peek now. C is what? Positive. B is what? Positive. So I know that both of my factors are going to be what? Positive. So I put plus, 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 plus. 1 plus 21 is what? 22. 3 plus 7 is what? 10. Which one gets me to B? The 3 and the 7. So now, remember what we have here. I can write this quadratic in what? Factor form, which is the product of 2 binomials. So I get x put into the first one. Now my second term is what? Plus 3 plus 7. What is this whole quadratic equal to? 0. What am I allowed to do from there? I can set x plus 3 equal to 0. I can put x plus 7 equal to 0. And now I can solve for what? X. So here we go. First step, simplify / combine like terms. Nothing to do. Second step, I'm going to what? Subtract. So I subtract 3, subtract 3. X equals negative 3. Let's solve for it over here. Now, simplify / combine like terms. Nothing to do. Step 2, I'm going to subtract. Subtract what? 7. Subtract 7. I get x equals negative 7. So my solution, x-intercepts, x equals 3, x equals negative 7. I want you to go ahead and get used to what is my x-intercept. Negative 3, 0, negative 7, 0. You can graph those 2 points. It won't help you yet until I teach you how to get to the vertex, but you're getting close to graphing a quadratic. Practice problem. Okay, let's put it all together. A golf ball is hit from a hill, and its height can be modeled by h for height, equals this quadratic. Negative 16t squared plus 32t plus 48, where h is what? Height. in feet, and T is what? Time in seconds. How long is the ball in the air? Now, this is where we can set it equal to what? 0. What are we going to set equal to 0? Well, h. Why are we going to set h equal to 0? Because h is the height. Now think about this. The height of a golf ball, remember, it starts on a tee. It gets hit. It goes up, and then it comes down. Correct? Now, let's consider the tee really not there. Let's say it's actually on the ground. It will also come back and hit the ground. What shape do you have? That's right, you have an upside down U, which is your quadratic. Okay? So now, I can find the zeros of the height, which is equal to the ground. So that's why we're going to set the height equal to 0, because that's when the ball was on the ground, it took off, and then it came back to rest on the ground. Does that make sense? All right. So now, if h is 0, negative 16t squared plus 32t plus 48. So what do? A is equal to what? Negative 16. B is equal to what? 32. C is equal to what? 48. Now, immediately what do you see? All of these are even numbers. So what should we always do? We should factor out a number. Now, does 16 go into 32? Yes, it does. Does 16 go into 48? Yes, it does. So now, I like when A is a positive one. How about we factor out a negative 16 in all of this? Okay, so that means I'm going to put my GCF, which is equal to what? Negative 16. I could take a negative 16 out of each one of these numbers. So I put my negative 16 outside, put my parentheses, remember, finding GCF, here's my deal. And now I divide each one of these by what? Negative 16. Why can't I take out a t? Well, I only have a t in this one, t in this one. Do I have a t over here in the third one? No. So negative 16 is my GCF. So negative 16 divided by negative 16 is a positive 1. So what's left? T squared. Positive 32 divided by negative 16 is a negative, because a positive and a negative is a negative. 32 divided by 16 is what? 2. So I get 2t. A positive 48 divided by a negative 16 is going to get me a negative. And 48 divided by 16 is 3. So all of this is equal to that, equal to 0. So 0 equals negative 16 times this quadratic, t squared minus 2t minus 3. Now I have something that's very, very simple. Okay, my new a is what? 1. My b is equal to what? Negative 2. My c is equal to what? Negative 3. What do? That's right, absolute value of a times absolute value of c. So here we go. 1 times positive 3 is equal to 3. Now what do? List my factors. Always start with what? 1 times 3. Does 2 go in? 3. I'm done. Good. Now, C is what? Negative. B is what? Negative. So I know I need a positive and a negative multiplied together. And since B is negative, the bigger number better be what? Negative. So the bigger number is negative. That means the smaller number is positive. When I add them up, they should get to b, which is equal to what? Negative 2. So 1 minus 3 is what? Negative 2. Does it work? Yes, it does. So now I can rewrite this as what? Negative 16. Don't forget it. And now, instead of writing the quadratic, I'm going to write the factor form and binomials, correct? So x goes in the first term. Now I use what? Positive 1, and a negative 3. Look at that. Man, oh man. All of that is simplified. That's as simplified as it can get. And now, since it's set equal to 0, negative 16 times 0, 0. And 0 times this, 0. So all I need to do is set x plus 1 equal to 0. X minus 3 equal to 0. Because if either one of those are 0, then I know anything else multiplied to it is going to be 0. So now I solve minus 1 minus 1. X is equal to what? Negative 1 plus 3 plus 3. X is equal to what? 3. So, factor form, where will this start? Negative 1, 0, and end at 3, 0. So think about this. Let's say that we had this golf ball, and it was on a grid. Well, it's going to start at negative 1. Right? They're going to hit it, and it's going to, I'm sorry, couldn't see. They're going to hit it, and it's going to do what? Land at positive 3. So that's how that looks. And that's how we can model the real world. I'm not sure if you're into sports at all. You'll see a lot of stuff on ESPN where they're showing how athletes are doing certain things, hitting a golf ball, catching a football, shooting a basketball, and they are using math to calculate speed, velocity, angle, trajectory, and where certain passes are going, where certain golf shots are directed, and the wind blows. All that is mathematics using these formulas. Okay?